To finish up section 17.4, we're going to look at two more encryption schemes, which are based off of the encryption schemes that we've already seen. So first, let's take a look at the linear cipher. This combines the decimation cipher and the Caesar cipher. A linear cipher is like first doing a decimation cipher to encrypt your message, and then encrypting it again using a Caesar cipher. So for this type of encryption, we need to choose a multiplication number k, which is an odd number between 1 and 25, but not 13, and a shift number s between 0 and 25. Then for each letter of the message I want to encrypt, I'm going to find the corresponding number a using the same chart as before. And this time I'm going to replace a with a times k, so that's the multiplication or decimation cipher part, plus s, that's the addition for the Caesar cipher, mod 26. And then find the corresponding letter for the encrypted message in my chart. So if we take a closer look at this, in the special case where k is equal to 1, then this is just going to become a plus s mod 26, so that is a Caesar cipher. If we have s equal to 0, then this is just going to be a times k mod 26, which is a decimation cipher. Since we can decrypt both the decimation cipher and the linear cipher, we can also decrypt the linear cipher. And there are going to be two steps to decoding a message encrypted with a linear cipher. First, we need to undo the shift of s, and we're going to do that by shifting again by 26 minus s. Next, we need to undo the multiplication by k by using the appropriate decryption value from the chart for decimation ciphers. So if I let t equal 26 minus s and j be the decimation decryption value that goes with k, then for each letter of the encoded message, I'm going to find the corresponding number in the chart, and then replace that number with itself plus t times j. So here I'm doing addition first and then multiplication, which is the opposite of the encryption. So decryption goes in the opposite order. And again, that's mod 26. And then I find the corresponding letter for the decoded message. So let's take a look at an example of decoding a message. A linear cipher with s equals 7 and k equals 21 has been used to create this encrypted message, and I want to decode the message. First, since s is equal to 7, then to decrypt the message, I'm going to use t is equal to 26 minus 7, which is 19. And since k is equal to 21, I'm going to look up the corresponding decryption value in my chart and find that I want to set j equal to 5. And then I'll just go through a similar process to what I've done before. So I'm going to copy my encrypted message down here and then find the corresponding number for each letter. So Z is 25, H is 7, Q is 16, and Y is 24 for my first word. For my second word, T is 19 and V is 21. For my last word, I is 8, L is 11, and U is 20. So I found my corresponding numbers. Now I need to do my modular arithmetic to find out what numbers those are going to be replaced with. So I just go through, and for each number I see up here, I need to replace that with the number plus 19 times 5 mod 26. This is my rule for decrypting a linear cipher. So for 25, I'm going to get 25 plus 19 times 5 is 220. Mod 26 is equal to 12. 7 plus 19 times 5 is 130. mod 26, which is equal to 0 because 130 is evenly divisible by 26. 16 plus 19 times 5 is 175. Mod 26 is equal to 19. 24 plus 19 times 5 is 215. Mod 26 is equal to 7. 19 plus 19 times 5 is 190. Mod 26 is equal to 8. 21 plus 19 times 5 is 200. Mod 26 is equal to 18. 8 plus 19 is 135. Mod 26 is equal to 5. 11 plus 19 is 1 times 5 is 150. Mod 26 is equal to 20. And finally, 20 plus 19 times 5 is 195. Mod 26 is equal to 13. So now I can replace my numbers with the new numbers. So 25 is going to become 12. 7 becomes 0. 16 becomes 19. And 24 becomes 7. 19 becomes 8. And 21 becomes 18. 8 becomes 5. 11 becomes 20. And 20 becomes 13. So those are the numbers for my decoded message, and now I just have to go back to my chart here and find what letters those correspond to. So here are my numbers for the decoded message. 12 is going to be M, 0 is A, 19 is T, and 7 is H, 8 is I, 18 is S, 5 is F, 20 is U, and 13 is N. So my decoded message is math is fun. The last encryption scheme that we're going to look at is the Wegener cipher, and this is also similar to the Caesar cipher. In this method, the letters of a message are shifted by a number of places determined by a keyword, which can be any word. For example, if I wanted to use the keyword agent, then using the letter chart, this keyword corresponds to 0, 6, 4, 13, and 19. Then to encrypt my message, I would shift the first letter by 0 places, the second letter by 6 places, the third letter by 4 places, the fourth letter by 13 places, the fifth letter by 19 places, and then repeat that pattern. So let's look at an example of a Wegener cipher. During the War of the Roses, a secret agent sends the message "The Duke is revolting" to Richard III, telling him that the Duke of Buckingham is planning a revolt. He uses the keyword agent. What is the encrypted message? So my first step, like always, is to write down my message and find the corresponding numbers in my chart. So my message is "The Duke is revolting." T is 19, H is 7, and E is 4. D is 3, U is 20, K is 10, and E is 4. I is 8, and S is 18. R is 17, E is 4, V is 21, O is 14, L is 11, T is 19, I is 8, N is 13, and G is 6. So these are the numbers that correspond to my message. Now I'm going to use a chart to help me encrypt this. So in my first row here, I've got my original message. In the second row, I've got the corresponding numbers for the letters. My third row has my keyword just repeated over and over again underneath the letters of my message. The fourth row has the numbers corresponding to the letters in the keyword. And then for each of these, I need to find the sum of the number in the second row and the number in the fourth row, and then find what that is, mod 26, and finally find what letter that corresponds to in my chart here. So for my next row, I'm just going to take the sums. So 19 plus 0 is 19. 7 plus 6 is 13. 4 plus 4 is 8. 3 plus 13 is 16. 20 plus 19 is 39. 10 plus 0 is 10. 4 plus 6 is also 10. 8 plus 4 is 12. 18 plus 13 is 31. 17 plus 19 is 36. 4 plus 0 is 4. 21 plus 6 is 27. 14 plus 4 is 18. 11 plus 13 is 24. 19 plus 19 is 38. 8 plus 0 is 8. 13 plus 6 is 19. And 6 plus 4 is 10. Now in my next row, I'm going to find what these numbers are, mod 26. So anything that is smaller than 26 is going to stay the same. So I'll still have 19, 13, 8, and 16. 39 is equal to 13 mod 26. 10 will stay the same, and so will 12. 31 is equal to 5. 36 mod 26 is 10. 4 will stay the same. 27 mod 26 is 1. 18 and 24 will stay the same. 38 mod 26 is 12. And then 8, 19, and 10 will all stay the same. So now I need to look up the letters in my chart. 19 is T. 13 is N. 8 is I. 16 is Q. 13 is N. 10 is K. 12 is M. 5 is F. 10 again is K. 4 is E. 1 is B. 18 is S. 24 is Y. 12 is M. 8 is I. 19 is T, and 10 is K. So this is the encrypted message using the keyword agent. An easier way to encrypt something with the Wegener cipher is to use the Wegener square. And this way you don't have to do all that arithmetic. If I want to encrypt a message, then I'm going to take the letter of the message to be encrypted and find that in the top row. And then find the letter of the keyword I'm using to encrypt it in the left column. And where those intersect, I'm going to find what my encrypted letter should be. So in my example, I was encrypting the letter H using the letter of the keyword G. So I would go down my column for H and find where that intersects my row for G. And that would show me that the encrypted letter is going to be N, which it was. I can also use this to decrypt if I know that the letter of the keyword that was used to encrypt a message was, say, J, and that the encrypted letter is T. Then I would just go to my row for J and go across until I reach T, and then go up to the top and find that the letter for the original message would have been a K. So encrypting, H was the letter G, gave me N. And then decrypting, if I knew the letter of the keyword was J and the encrypted letter was T, then that gives me K as the original letter. So this slide just has half of the square. I only go from A to M on the left here. And the rest of the square is on this slide, going from N to Z in the letters of the keywords. And this chart is also in your book. Things you should know for this section: you should be able to understand modular arithmetic. You should also be able to use encryption schemes to encrypt or decrypt a message. And that will be what's on your homework. If you're interested in the history of codes, you can read more about them at this website, which is pretty fun to explore.